So in the last video, we left off with the question, why do we have rocks with different names here, rhyolite, granite, and pegmatite, when they all have the same minerals in them, potassium feldspar, quartz, plagioclase, biotite, and amphibole? And that is an important question to answer. So the reason why they have different names has to do with where they were made, or what we call the environment of formation. And we're going to look at, was the rock quote unquote microwaved or slow cooked? So if you cook something in the microwave, you want it fast, you want it quick, and it may take a minute or a couple minutes tops. If you want to have a better meal, in my opinion, you cook something in a crock pot, which is a slow cooker, and it cooks for hours and hours, 6 hours or even more. So igneous rocks, we can kind of make a comparison to, because some form in the microwave and some are slow cooked, or slow cooled, I should really say. So the whole idea, which is important, is when lava or magma cools, the atoms arrange to form the crystals. And the more time they have to organize, the larger the crystals are going to be. So when the lava or magma finally cools, the crystals get locked in place. But up until that time, they're rearranging and organizing and growing. So the longer it takes to organize, the longer it has to organize, the bigger the crystals. And you know this from experience too. It takes time to organize your notebook, time to clean up and organize your room. So we're going to see that come to be in our rocks. So the environment of formation determines the texture, and what is texture is straight from your reference table. And when you look at the page in the reference table, and again, we're on page number 6, the texture is not how the rock feels, which may be how you use that word in your just regular life, but in terms of the scientific meaning, it's the size of the mineral crystals. And in your reference table, it actually tells you if you forget. So texture is the crystal size. And we have different grades of texture. If it has no crystals, it's called glassy. If the crystals are there but microscopic, really tiny, or less than a millimeter, it's called fine textured. If they're 1 millimeter to 10 millimeter in size, it is called coarse. And now these we can actually see with our unaided eye. We don't need a microscope for that. If they're 10 millimeters or larger, then they're supercrystals or very coarse. We also have another designation over here of non-vesicular and vesicular. Some rocks cool so quickly that the gases that are in them get trapped, and the lava actually cools around the gas, leaving these bubbles or pockets. So you're only going to find vesicular texture in quick cooling rocks that are glassy or fine, and we're going to take a look at them in a minute. Non-vesicular means there's no little bubbles or gas pockets in it. So here's our microwave and slow cooker idea. What controls texture is how fast an igneous rock cools, and what controls how fast an igneous rock cools is where it formed. So deep in the ground is going to be our slow cooker, or rather slow cooler. When it's underground, it's insulated and it doesn't lose the heat quick, so it cools really slowly. And there's time for crystals to grow and organize into bigger, coarse ones. Our microwave cooler is on the surface. The lava there cools very fast, and there's no time for crystals to grow very large, and in some cases, they don't grow at all. So here we have an example of rocks that form below the ground, and that's a term we're going to use called intrusive. So this is our slow cooling rocks down here. And then we have our fast cooling rocks, or our microwave cooling rocks, up here. And so here's an example of a rock that has visible crystals because it cooled slowly underground. I'll bring that to the side. And here is another rock that cooled very slowly. And you can see it has big crystals, and they look like chunks of color, almost like if you had ice cream with different candies or chips in it. You can see different textures here and different minerals. We have mafic rocks that are dark colored. It's a little harder to see the mineral crystals because they're all darker black. And so there's a chunk and a chunk there, and you can see this might be plagioclase feldspar, a chunk over here, but it's a little harder to see the individual minerals, but you can see a texture of coarse size to it. And then we have a couple more rocks here where you can see there is texture, there's coarse crystals. Now up here on the top, where the lava cools, and remember that down here would be magma. Magma is just below the ground. Up here is lava. The only difference is where the molten material ends up. You can see now this rock over here doesn't have any chunks of crystals that are visible. It doesn't have a coarse texture. This is fine. Down here is the equivalent of that cooled below ground. Here is another rock that doesn't have any visible crystals. Both of these look creamy. No little individual crystals are able to be seen unless you had a microscope and had a slice of the rock that was really thin. This is the equivalent of this rock up here that cooled slower below ground. So same minerals here and here, just where it cooled is different. And then we have our vesicular rocks over here. So here is a rock that cooled so quickly that the gas didn't escape and took up a parking spot, so to speak, over here, and the lava actually cooled around it. And we can see a mafic version of that over here with little Swiss cheese pockets in here as well. Finally, we have rocks that cooled so fast there's no crystals that formed at all. Here's a rock that is a glassy texture. It's called Obsidian. And it has no crystals at all. This is a non-crystalline rock. So we're going to actually now color in our reference table based on this scheme. And what I'd like you to do is fill in the table as I have over here on your own reference table. So down here, I'd like you to color things that are labeled here. So potassium feldspar, color it pink or white. I used a computer and couldn't really get down here neatly, but you can with colored pencils. Pyroxene, color it dark green, and olivine a little lighter green. So that's the first thing I'd like you to do. You can pause the video to do that. All right, the next thing I'd like you to do is make a dividing line here between intrusive rocks, also called plutonic, that cool underground, and extrusive rocks that cool above ground. So here's our microwave cooling, here's our slow cooker cooling, and there's that term environment of formation. And what we want to do is also draw a little volcano above ground and write lava, and draw a pool of magma below ground and label it magma. Then finally, what we're going to be doing on our reference table is we're going to be making a key for these things, so it's a little more visual. Very coarse crystals, we're going to use a big diamond for. That's representing a crystal. If it's just coarse, make your crystals smaller. If it's fine, we're going to make little dots, tiny crystals. If it's glassy, we're not having anything at all because there's no crystals. And if it's vesicular, then we're having the little gas pocket. And then what you're going to want to do is any rocks that line up with very coarse, which we only have one called pegmatite, you're going to draw the big diamonds in. Any rocks that line up with the coarse, we're going to put the smaller diamonds in. And make a note that this rock diabase can either be coarse or it can be fine. That dividing line runs right through it. So the fine rocks are going to be also diabase, basalt, andesite, rhyolite, vesicular rhyolite, vesicular andesite, and vesicular basalt. Again, everything that lines up with fine over here. And these are all our glassy rocks up here where we have no symbol. And then we have vesicular, which could be in a fine rock or glassy rock, and they line up as I've demonstrated over here. So please take a moment and you can pause the video or the program will pause it for you to do this. Now what you want to be able to do is use your table to identify an igneous rock, and we're going to start with this one over here. So the first thing we have to do is take a look at its color. Is this a lighter colored rock or a darker colored rock? Is it felsic or is it mafic? And although this rock has some dark specks in it, it's mostly light. So now we know for sure that we're on the felsic side of our chart. We can see potassium feldspar in here. There would be quartz, plagioclase, biotite, and amphibole. Now the second thing we look at is its texture. Do we see crystals? And yes, we do. So that would mean it would be either very coarse or coarse. And we'd actually have to take out a ruler and measure if they're 10 millimeters or a centimeter or larger, or if they're less than that. And on this computer program, we can't do that. So this rock could be either. So that means that this rock would either be a granite or a pegmatite, depending on the size of the crystals over here. Now what we can do is take out the equivalent to that cooled quickly above ground. This is a microwave cooled rock. Same light color over here and lower density. But since we don't see any crystals in here and it looks creamy, it's going to be fine. So it has to be rhyolite. Why can't it be vesicular rhyolite? Is that we don't have any gas pockets in it. And then we have over here the opposite of that. Now we have a rock that is dark colored. So therefore we have to be mafic, higher density, rich in iron and magnesium. And now you need to look at the texture again. What would the texture of this rock be? And hopefully you know now it's fine. So this rock now has to either be diabase or basalt. Now why can't it be vesicular basalt? Well, vesicular basalt is down over here. So same idea, dark, can't see any crystals, but has the gas pockets or bubbles in it. Let's try this rock over here. Okay, what do you think this rock would be classified as? So we'll do color first. Is it mafic or is it felsic? And hopefully you recognize it's light colored and felsic. Notice we have the Swiss cheese pockets in here and we don't see any crystals, right? So what rock could it be? So we have to be on this side over here, right? We have to be vesicular. So according to our chart, it's either going to be pumice or it could be vesicular rhyolite. In this case, the rock was pumice, but if you thought it was vesicular rhyolite, that's fine because that's it does look similar to that. It's just that this rock technically is glassy, but it's hard to see that from a picture especially. And then we will see a glassy rock over here. And this is a confusing one because this is a dark colored looking rock, but it's called obsidian and it's on the felsic side of your chart. So there's your glassy obsidian. And obsidian, if we took a really paper thin section, like a deli thin slice, it would actually let light through. It's just that with glass, when you have layer upon layer upon layer and it gets really thick, it traps light. Light doesn't reflect off of it back to our eyes, so it appears dark. It's a light absorber. So obsidian is an exception that it looks mafic, but it actually is felsic in a thin section, and it would be on this side of the table. All right, one more. we have rocks that fall in between the two extremes. This rock looks like it is a little bit of both felsic and mafic. So that means we're an intermediate rock in the middle. Is this rock then diorite, andesite, or vesicular andesite? Well, since we see little crystals in it, since we see crystals that are visible to the eye, then it has to be diorite. And we call this an intermediate rock again because it's partly mafic, partly felsic. The last thing I want to talk about is what's called ultramafic, even though it's also not on your table. Pyroxene and olivine are very dense minerals, and the rocks that have them are extremely dense. So here's our dunite, and here is our peridotite. And even though I know they don't look as dark as like this mafic rock over here, they are actually called ultramafic rocks. They're especially dense and especially rich in iron and magnesium. So that ends our discussion of how to identify an igneous rock using its composition or its color and its texture.